Chapter 9, Stress Transformation. In this problem, we have a parallelogram with the angle of 30 degrees at one side with the shear stress of 10 megapascal. We want to calculate the principals, or the principal stress, which is sigma max and sigma min. So let's see how we can approach this problem. If we just take out a triangular sample of this problem like this one, if we can take it out here and observe the effect of stresses on that sample of the triangular sample, we can have a shear stress of 10 megapascal at the top, like you can see here, and a 10 megapascal shear in this tilted line over here, which we just translated on this in plane, and a negative sigma x, which is in negative of x direction, and also a shear again, which is the amount of 10 megapascal. So again, if we want to calculate the principal stresses like sigma min and sigma max on this tilted edge, we can just take out this triangular element out and see the effect of stresses on that piece of element. So we have a 10 shear, 10 megapascal shear, and degree of the, then we need to translate this length over the of hypotenuse to the vertical axis and horizontal axis to get the forces. So we just take out this rectangular element in 3D format. You can easily see that if we just, this is the 30 degrees, this is our hypotenuse of all, and this is a 90 degrees. We want to write down summation of forces in x direction. In positive x direction goes 0. We do not have a unknown negative sigma x because that's on negative x direction, and that's our only unknown. And in the other side, we just have some stresses. At the same time, we do know force is equal to stress times the area. So if we just multiply, create an area to multiply by this stress, either in shear or normal, we can get the forces. So let's see, if we call this length like dl, this tilted line, the length of this line is dl, we can project it in x-axis by dl cosine of 30 degrees. The length at the top is dl times cosine of 30 degrees. If we just translate the hypotenuse to y-axis, that's a dl like sine of 30 degrees. And then if we want to know, create an area, if we just consider the other dimension, like to the board or out of the board is 1, with 1, it's just dl cosine of 30 times 1 gives us the area. So dA times the stress, or area times the stress, is our force. Then we can jot down this equation for equilibrium of equations in x direction, because just be careful, we can write down the equilibrium equations just for forces, not the stresses. So at the same time, we can project this one in x-axis also. So if that's 30 degrees, this is also 30 degrees, this is 30 degrees, and can easily say that this is also a negative because it just goes in negative x direction, and 10 again because of shear stress at the side is in 10 megapascal times dl, again cosine of 30 degrees. So we have a negative sigma x which acts on plane of sine of the, forget about 1, just cancel out 1 there, and negative 10 times dl cosine of 30, again minus 10 times dl cosine of 30 at the top, This is this one, and negative also. That's the direction. And also another negative 10 times dl cosine of 30, which is here. And then we don't have any other forces, so it just gives us, if we cancel out dl with each other, and also sine of 30 is 1.2, cosine of 30 is square root of 3 over, cosine of 30 is also again of 2. Just write down the equation of sigma x and cancel everything. Sigma x is a negative 20 times a square root of number. So as soon as we know sigma x is a negative, it just means the direction is in the other side. That's a compressive stress. Sigma x is a compressive stress there. And if you look at this plane, which is plane of x, and we call the plane by their normal. So the normal of this plane is sigma x, so we call this plane like normal, the plane of x, and that's a negative, that's sigma x, and tau xy, that's a negative 20 times the square root of number 3 and a negative 10. If you want to know why that's negative 10, you have to consider the other side of the, have an element like this, and all the time the two forces should be at the balance condition. So if this is a negative, this is a 10 megapascal, look at to the other side of it, because most of the time we just consider the element from right to the left. So look at this element. So this is a 10 and it's just going downward. That's a negative direction. We just consider a positive shear in the positive y direction. This is a negative downward, so that's a negative 10. This is also negative 10, but it just appears on the back of our element. So we just concern for this part of the, so it just gives us a plane of x like what you can see here. And let's see how about plane of y. Plane which has normal of sigma y is plane of y, and you can easily see there is no nothing in y-axis, there is only a shear of 10 megapascal. So plane of y is represented by capital Y 0, and if this is a negative, the other one is positive. The shear stresses, if you remember, with two, just draw the Mohr circle. If one of the shear, which is tau, is positive, the other one is negative. One of them are negative, the other one is a positive. It's just they are opposite of each other. That's the point. As soon as you have that, then sigma max is average stress plus radius, and sigma minimum is sigma average minus r this time. Let's calculate average and r, then we can have everything for calculating the principles. So sigma average is simply if you have two numbers, the average of them is just simply add them divided by 2, just gives you the average. And sigma average is a negative 10 times square root of number, and for that's a sigma average. And for calculation of R from chapter 9 stress transformation or Mohr circle, you can easily see square root of sigma x minus sigma y over 2 parentheses square plus tau squared is the amount of shear maximum, tau maximum, or radius of our Mohr circle. That's a negative 10 square root of 3 squared plus 10 squared. It just gives us a square root of 400, and our R is equal to 20 megapascal. The unit is also megapascal. As soon as we have average and radius of our Mohr circle, we can easily calculate our principal. If you subtract R from average, it just gives you sigma mean, which is a negative 10 times square root of 3 minus 20. And if you add the radius to sigma average, it just gives you sigma maximum. So you can easily see sigma maximum. Our problem is point positive 2.68 68 megapascal, and sigma is negative 37 pascal. Thank you. Solve more problems.